Imagine lying beneath a clear night sky, looking up at thousands of stars scattered across the darkness. And as you stare into that vast emptiness, a familiar thought comes to mind. Maybe it began in a lecture you once attended, a documentary you watched, a book you read, or a movie that left you wondering. Black holes. It's a name almost everyone has heard. Yet the more you think about it, the more questions appear. What exactly are they? How do they form? How large can they become? Primordial black holes. Long before the first stars illuminated the universe, space was a very different place. The young cosmos was unimaginably hot, dense, and chaotic. Tiny fluctuations in matter and energy filled the newborn universe. Most disappeared as space expanded, but some regions may have been different. If a patch of the early universe became dense enough, gravity could have crushed it into a black hole. Not from a dying star, not from a collapsing galaxy, but from the birth of the universe itself. These are known as primordial black holes. If they exist, they could be older than every star you have ever seen, older than our sun, older than the Milky Way itself, ancient survivors from the first moments of cosmic history. And some scientists have proposed an even more intriguing possibility. What if part of the mysterious dark matter filling the universe is actually made of primordial black holes? The idea remains controversial. But if it's true, these ancient objects may be helping shape the universe even today. Micro black holes. When most people think about black holes, they imagine something enormous. But some theories suggest black holes could also exist at the opposite extreme. So small, they would be impossible to see. These hypothetical objects are called micro black holes. They became famous because of a surprising question. Could humanity accidentally create one? The concern emerged during the construction of powerful particle accelerators, like the Large Hadron Collider. If particles collide with enough energy, could a tiny black hole appear? According to current physics, even if one formed, it wouldn't survive for long. It would evaporate almost instantly, through a process known as Hawking radiation. Rather than consuming Earth, it would disappear before it had time to do anything at all. Yet micro black holes remain fascinating, because they sit at the intersection of gravity and quantum mechanics, two of the most successful theories in science, and two theories that still refuse to fully agree with each other. Stellar mass black holes. When most people picture a black hole, this is what they are imagining. A stellar mass black hole begins its life as a massive star. For millions of years, that star fights a constant battle. Gravity pulls inward, nuclear fusion pushes outward. As long as fuel remains, the balance holds. Eventually, the fuel runs out. Gravity wins. The core collapses, and a black hole is born. The star disappears. Its gravity remains. These objects typically contain several times the mass of our sun, packed into an incredibly small region of space. To understand how extreme that is, imagine compressing an entire star into a volume smaller than a city. Although black holes emit no light, astronomers can still find them. Nearby stars orbit something invisible. Gas heats up as it falls inward. Light bends around empty-looking regions of space. Sometimes the best way to discover an object is by observing what it does to everything around it. Rogue black holes. Most black holes remain close to where they formed. Not all of them. Some travel alone. A powerful stellar explosion can occasionally launch a newborn black hole across the galaxy. After that, it begins a lonely journey through interstellar space. No companion star, no bright disk of gas, no obvious sign that it's there, just gravity moving through the dark. These are known as rogue black holes. Finding them is extremely difficult. In most cases, the only clue is the way their gravity affects nearby objects, or bends distant light. And here's the unsettling part. Somewhere within the Milky Way, there could be millions of them. Most would never come near us. But if one passed through our region of the galaxy, we wouldn't see it coming. Not because it's moving too fast, but because black holes don't need light to exist. They reveal themselves only through gravity. And gravity is easy to ignore until something starts moving where it shouldn't. Binary black holes. Now imagine two black holes, locked together by gravity, orbiting each other, slowly spiraling inward. As they move, something extraordinary happens. They create ripples in space-time itself. These ripples are called gravitational waves. Einstein predicted them in 1916. For nearly a century, they remained purely theoretical. Then, on September 14, 2015, a signal arrived. It lasted only a fraction of a second, but hidden inside it was the final moment of two black holes colliding more than 1 billion light-years away. Humanity had spent 100 years searching, and for the first time, the universe answered. The discovery changed astronomy forever, because we were no longer observing the universe only through light. For the first time, we were listening to it through gravity. Intermediate mass black holes. Astronomers have discovered small black holes. They've discovered enormous black holes. But for a long time, something seemed to be missing, a middle ground. This is where intermediate mass black holes enter the story. They are thought to contain hundreds or thousands of times the mass of the Sun, too large to be stellar black holes, too small to be supermassive giants. Finding them has proven surprisingly difficult. Yet they may hold the answer to one of astronomy's biggest questions. How do supermassive black holes become so large? Do smaller black holes merge together over time? Do they grow slowly by feeding on surrounding matter? Or did some begin their lives already massive? Intermediate black holes may represent a missing chapter in that story, a bridge connecting what we know to what we still don't understand. Supermassive black holes. At the center of most galaxies lies something extraordinary, a supermassive black hole. These giants contain millions, or even billions, of times the mass of the Sun. Our own galaxy is no exception. At the heart of the Milky Way sits Sagittarius A star, an invisible object powerful enough to control the motion of stars across vast distances. If our entire solar system were placed near one of these giants, the planets would seem almost insignificant by comparison. For decades, scientists could only infer their existence. Then, in 2019, the world saw something remarkable. The first image of a black hole's shadow, a blurry ring of light surrounding a dark center in the galaxy M87. Not a movie effect, not an artist's impression, something real. When supermassive black holes actively feed on surrounding matter, they can become quasars, objects so luminous they outshine entire galaxies. Some also launch enormous jets of particles across space. When one of those jets points almost directly toward Earth, astronomers call it a blazar. These giants do more than sit inside galaxies. They help shape them, influencing stars, gas, and the evolution of entire cosmic structures. Naked singularities. Every black hole hides a mystery. At its center lies what physicists call a singularity, a place where our current equations stop providing meaningful answers. Normally, that singularity remains hidden behind an event horizon, the boundary beyond which nothing can escape. In a sense, the universe draws a curtain over the unknown. But what if that curtain didn't exist? This possibility is known as a naked singularity, a hypothetical object where the most extreme region of space-time is exposed to the outside universe. If such an object exists, it could challenge some of our deepest assumptions about physics. Perhaps nature prevents them from forming. Perhaps they are impossible. Or perhaps we simply haven't found one yet. And that uncertainty is what makes them so fascinating. Because at that point, we are no longer asking what a black hole is. We are asking where the limits of reality itself begin. Which one made you stop for a second? Drop it in the comments. And if you want to keep exploring the strange places, subscribe and come back to Noverse.